I want to talk about this real quick. This right here, this line here is continuous between -3 and 0. So it is continuous. But this break right here means that the function or the graph as a whole is discontinuous. It's discontinuous if there's a break. Anything that looks like a cliff. You hit something and the only starts way back away from it. Even if it's just one point that's missing in a line. If I have a line that looks like this and there's one point in there missing and I continue on, that's still discontinuous because there is some kind of a break. Okay? Discrete functions look almost like, well, they are. Scatter plots are discrete. This function here is discrete. This function over here is continuous. Okay? And so I want to look at what this looks like. Our domain here will go from -infinity to 0, and it will touch 0. So our first function is going to be x is less than or equal to 0, our first domain. The second, third, fourth, and fifth, each one of these is going to have a separate domain. So if I look at this point, it's at 1, 3. This one is at 2, 2, 3, 2, and 4, 1. They're not connected, and so each one of these is a separate function. So here, I'm going to just have x equals 1, when x equals 1, when x equals 2, when x equals 3, and when x equals 4. And I have to do this because these are very specific points. Now, our first function here is function a. Let's look at it. This is a quadratic function that's at 0, so it's where it belongs. If I had drawn in the rest of it, it would look like it was over here. But I'm only taking the points that are 0 or less. So it's still the quadratic function, just like normal, but we're only looking at x being a quadratic function when x is less than or equal to 0. Now, when x is equal to 1, y is equal to 3. So when y equals 3, it means x equals 1. When y equals 2, x equals 2. When y equals 2, x equals 3. Okay, when y equals 1, x equals 4. We could have combined these two just by doing comma or 3, okay? But we don't have to. We can leave them separate like that. And again, this is a discrete function. This is a continuous function, okay? When you are looking at the piecewise functions, it's easy to get kind of lost in them when you're actually defining them. I think it's easier to go from the definition to the graph, but a lot of students don't. A lot of students have an easier time writing the functions. So we can look at this one, and we're going to be going backwards. We know what the functions are, but we don't know what it looks like. Now, when I'm doing this, I have a -4 is less than or equal to x, which is less than -1. That means I'm going to have this function sandwiched in between -4 and -1. So I'm going to just draw a little dotted line at -1 and at -4. Because I know this function is in between there, okay? Then I have another function between -1 and 2. We already have -1 marked, so let's mark 2. And then our last one is between 2 and 5, so I'll mark 5 also. So I'm going to have 1, 2, 3 parts. I have 3 functions, okay? When I look at a function like this, the 3x minus 1, I could go to -1 and do down 3 and over 1, and I can come up with where it should be. It's easier to take these two endpoints, though. If I take 3 times -4 minus 1, that will equal to -12, -13. Okay, so at -13, at -4, -13, this function exists. So let's make each of this 2. That's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So right here at -4 and -4, -13 is an end point. So it will be solid. Now it doesn't touch -1, but it gets very close. So